Hello students. So today discussion is about air and its constituents. So do you think air is very important for us? The answer is absolutely yes. If there is no air, there is no survival, there is no life also. Yes or no? Why? How air is helping us? Because of air only, na students, we are able to respiration is taking place. Because of oxygen gas, yes or no? And because of this water vapor only, na students, all these rain formation, evaporation, the whole cycle of water cycle is depends upon. And because of air, because of oxygen only, na students, the particular combustion reactions are taking place, the burning reactions are taking place. Because of the presence of certain very limited amount of carbon dioxide only, students, the earth is becoming little bit warm and maintain its warmness throughout. If there is no carbon dioxide, what happens? The shady side of the planet Earth, that means opposite side, when it goes rounding around the sun, the opposite side, the night side becomes very extreme cold. Then why is it becoming extreme cold? No. Why? Because of the presence of CO2. But your doubt, sir, CO2 is harmful. Yes, it is. Excess amount is harmful. But whatever that 0.0 to 0.03% is, that is good for our planet Earth only. Why? Because CO2 can trap the heat energy, and this heat energy is the reason why during the night times we are not feeling extreme coldness. Yes or no? Look at other planets. What the scientists are searching for? They are searching for life. There are two things they are searching for before they want to focus on any planet or the moon of the planet. You know what is that? Presence of water, H2O, as well as presence of atmosphere onto that planet. Recently, Titan, the moon, the Titan, students, it has atmosphere. It has atmosphere. So atmosphere is one of the essential thing for the life, for the survival of the life and for the existence of the life itself. Understood? Why? Because for the respiration, for evaporation, cloud formation, everything, for combustion, the components of air are very, very necessary. Nitrogen gas also one of the key component for the plant's growth. Yes or no? So this chapter is very, very important, students. Air is found everywhere on the earth. Living things cannot survive without air, right? And air is necessary for breathing and combustion. Combustion means burning reactions. Sir, why do we need to burn? For all cooking purpose, for all the factories, for all the transportation purpose, what we are doing? Burning only. Yes or no? So the earth is surrounded by an envelope of air that is called as atmosphere. The earth is completely surrounded by an envelope of air that is called as atmosphere. This atmosphere is the crucial thing for the survival and existence of life. So composition of air, like what the air is made up of, what does it contain? That is composition of air. So these are the key components, students. These are the gases present in the air. Nitrogen, how much percentage? 78%. Major share in our atmosphere is nitrogen. Oxygen, how much? 21%. Carbon dioxide, 0.03 to 0.04%. Don't feel carbon dioxide is good. This much level is good. If you increase, that's a problem. Inert gases. What are inert gases? Inert gases: helium, neon, argon, krypton, xenon. Yes or no? These are all the inert gases. Their share is 0.90%. Water vapor, it depends. Water vapor depends. And impurities and dirt particles also varies, means it depends. Of course, they are also not fixed. They are also not fixed. For example, in the industrial area, carbon dioxide, do you think it is only 0.03%? No, it increases a little bit. In the forest area, oxygen levels are more. Understood, students? That's why forest fires mostly happen. More oxygen content. So they are also not exactly, but in overall, in an average, this is the percentages. So this is what the air is made up of in our planet Earth. So air is a mixture, not a compound. So this is very, very important discussion. Air is a mixture, not a compound. So first of all, what is the difference between a mixture and a compound? Let us define what is a compound and what is a mixture. Compound means when two or more elements combine chemically to form a new substance, to form a single substance. That is called as a compound. That is called as, students, a compound. Mixture. Mixture is also combination, but not chemically. Understood? Mixture also combination only, but not chemically. Give an example. When hydrogen gas combines with oxygen gas chemically means they undergo chemical bond formations, they produce water. That's a compound. H2 is a compound. Sodium chloride, when added to water, it forms a salt solution. It's a mixture. Is sodium chloride reacting with water? No. Is it chemically combining? No, it is physically combining. That combination is called as physical combination. Right, students? So now air, is it a mixture or a compound? Air is a mixture. That means the components of air. What are the components of air? All these nitrogen gas, oxygen gas, carbon dioxide, water vapor, everything. Are they chemically combined or physically combined? Mixture means these components are physically combined, not chemically. Do you think there is any bond between carbon dioxide and water? Is there any bond between oxygen and nitrogen? No. Got the clarity? CO2 is CO2. Of course, bond between carbon and oxygen, CO2 molecule, that's a different compound. Oxygen gas, different molecule. H2O, a different compound. Sir, students, got the sulfur dioxide, different compound. So all these are the compounds, all these are compounds which are mixed physically, to form air. That air is made up of different compounds. Are all these compounds chemically combined or physically combined? Physically combined. That's why all together air is called as a mixture. All these compounds are physically coexist together. That's why it is called as a mixture. So these components exist in the air as separate. They're separately, sir, no. Non-reactive, are they reacting in the air? Hydrogen, oxygen combining to produce water in the air? No. Unbound entities, do you find any bonding between one compound and another compound? No. Like entities means molecules. So if air was a compound, the above mentioned gases would be chemically bound together in some sort of fixed ratio. So why this discussion about air being a mixture, not a compound? Why? Because students, in the ancient philosophers, they thought like air is an element. Air is an element. That's why all this discussion. So air is not an element. Air is a mixture of different compounds. Every compound is made up of some set of elements. Yes or no? So that is what the point. So next, what are the characteristics of air as a mixture? Like what are the properties and what do it exhibit of being a mixture? So the composition of air varies from place to place and from time to time. For example, the percentage of water vapor in air depends upon both place and season. Yes or no? Water vapor, is it same in everywhere? No. Water vapor, the percentage of humidity is more in near the coastal areas. Yes or no, students? As well as the percentage of oxygen, it is more in the forest areas. The percentage of CO2 is more in the industrial area, not even in the industrial area. If you can check the rural and urban areas, in the urban areas, students, the percentage of CO2 is more. Yes, sir, in the rural areas, it will be less. Why? Because urban areas mostly contains factories. So that's why. So it depends. The composition depends upon place to place as well as time to time. Depends upon the weather conditions also. So no heat change is involved in the mixing of two gases in the air. So what's the meaning of this point is that, students, the reason is, so some chemical reactions takes place either by losing energy or by gaining energy. So an exothermic and endothermic reaction. So is it happening when these molecules are in the air, any energy is lost and energy is no. Of course, these gases are absorbing energy from the sun, that is okay. But are they in the process of reactions? Is it happening? No. That's what the point says. So no definite boiling points for liquid air. So what is boiling point? The temperature at which a liquid changes into vapor is called as boiling point. So what is the boiling point of H2O? 100 degrees Celsius. Like that boiling point of CO2, boiling point of N2. Every compound has its own boiling point. Can you say a single boiling point for air? No. Why? Why? Because air is not a single substance. Understood? So it is made up of different compounds. Every compound has its own melting points and boiling points. So air has no definite chemical formula. Correct. What is the formula of carbon dioxide? CO2. What is the formula of water? H2O. What is the formula of air? Can you write like CO2, H2? No. You're saying the composition, that is not the formula. When you have to say the formula for a chemical substance, you have to say the formula. Okay, understood, students? So air is not a compound, a single substance. It is a mixture of different components. So look at the point. The separation of air into various components can be done by the physical methods. So separation of air into various components can be done by the physical methods. Like for example, H2O. Can you separate H2O by physical methods? What are physical methods? Filtration, evaporation, distillation, hand picking, all these things comes under physical. Can you separate a H2O by physical methods? No, you cannot. Why? Because H2 is a compound. Can you separate air by physical methods? Yes. Why? Because air is made up of different components. All these components can be separated by fractional distillation, liquefaction techniques. These are physical techniques. Why not chemical? Why? Because they are not chemically combined. The molecules and the molecules, are they chemically combined? No. Understood? They are separate entities. So air does not exhibit definite chemical properties of its own. Every compound has its own chemical formula. Altogether, does it have a single? No. Every compound has its own properties. The components of air retain their individual properties. That's what the point says. CO2 has its own property, H2O has its own property, O2 has its own property. Understood? For example, oxygen. Oxygen gas is a supporter of combustion. CO2 is a fire extinguisher. It put off the fire. It stops the fire. Yes or no? CO2 is acidic in nature. Oxygen is neutral. Understood? Like that. Air contains many gases like nitrogen, oxygen, carbon dioxide and water, right? Correct? So what are the important properties of air? The general properties which air exhibit. So air is a colorless gas. It's a colorless gaseous substance, right? Can you see any color? It's a colorless substance, yes or no? Air has volume and occupies space. What is volume? The space occupied. It is occupying the space, right? It has volume, it is matter. Third state of matter. So air has weight and exerts pressure in all the directions. Air has weight. Is it correct? Does it have mass? Yes. Air has a fixed mass. Some students will think like, sir, we can't feel now. Yes, we can't feel. Why we can't feel? Why? Because we already evolved in this environment, students. And altogether air is, molecules of air separated by many distances. Yes or no? There is big intermolecular spaces. If altogether combined some moles and moles of air, you can feel that it has weight. A molecule is not changing, right? The molecule of H2O in solid or in liquid or in vapor is not changing. Then why weight changes? What is changing? The distance between the molecules are changing. Understood, right? So air usually contains some water vapor, obviously, because of the process of evaporation. Air usually have some speed. Wind movements, yes or no? Wind is moving from higher concentration to the lower concentration. So air has temperature because of the sun, right? Correct. So the first component which we need to study from the air is oxygen, one of the most essential element, molecule of element for our survival. Not only for us, it is essential for all the organisms, living things. So history of oxygen. Air contains how much? 21% of oxygen gas by volume, students. Later on, it was Antoine Lavoisier who proved that oxygen is an element, and he named this gas as oxygen, which means acid former. First, Joseph Priestley, he is the one who discovered this, but he didn't explain the elemental nature of oxygen. Later, Antoine Lavoisier, he proved oxygen as an element, and he named it as oxygen. Oxy means acid. Why? Because he believed that all the acids contain oxygen, but which is wrong, but the name remains. Okay, acid former. But it is an acid former, students. When this oxygen, when it reacts with non-metals, it produces non-metallic oxides which are acidic in nature, but not every time, correct. If it reacts with metals, they produces bases, right? So that's a history, small history. Significance of oxygen in the atmosphere. This is a general topic. Significance, where it is used for respiration, yes or no? Everywhere. It supports all the animals and plant life on the earth, as it is essential for the respiration. We absorb oxygen, releases carbon dioxide. Are we taking only oxygen? No, all the air, from that air oxygen gets absorbed. It is essential for the combustion of fuels. Man burns an enormous amount of fuels for his energy needs. Oxygen helps in the combustion of fuels to form carbon dioxide and water vapor as main products. Students, energy. So why do we need energy for cooking? Yes or no? Why do we need energy for electricity, wind energy, hydro energy? Yes or no? And why do we need energy for any preparation of any useful products in the industries? And why do we need energy for the transportation, vehicles, two-wheeler, three-wheeler, four? How everything is running, the whole? Because of energy only, students. Yes or no? So all these energy, the burning, for burning, what is essential element? Oxygen. Oxygen gas is one of the most essential thing for burning process. What is happening during that? So we'll, of course, we have the combustion reactions also, there we'll discuss in detail. So in the presence of oxygen only the combustion, the burning takes place, students, and which is our essential needs. So in nature it dissolves in water. This in turn helps to keep the fresh water fresh and is a source of respiration for water animals also. The dissolved oxygen present in the water makes the water fresh. Why? Because, students, other impurities, dust particles, any formations, life formations may happen, but this space is occupied by the oxygen. That doesn't mean, students, oxygen is present everywhere. A very little percentage of oxygen only present, that makes water fresh. That effect of, when you're drinking water, it makes, feels like fresh water because of oxygen. And this oxygen present in the water is also one of the main reason for the survival of aquatic life. What is aquatic life? All the plant life and animal life living under the water. Yes or no? How they are breathing? Because they have some separate evolution. Okay, sir, from the gills, they can breathe oxygen directly from the water. So that's how it is. Occurrence of oxygen, like where do we can get this oxygen? How do we get this oxygen? Oxygen is most abundant element occurring on this earth. Abundant means, students, here one point, sir, oxygen present 21% only, nitrogen 78. Why oxygen is most abundant? Why? Because, students, oxygen in the air, it is 21% only, right? Correct. But oxygen, it is also found in the earth crust in the form of oxides. So altogether, if you can check, oxygen percentage is more, not only in the air, in the earth crust also. So both in free as well as in the combined state. Free state means oxygen gas, like that is also combined with the oxygen only, right? Combined molecule of element. So if it combines with aluminum oxide, most of these metals combines with oxygen present in the earth crust. Aluminum oxide, magnesium oxide, sodium oxide, iron oxide, yes or no, mostly copper oxide. In combined state, 8/9 part of the weight of water contains oxygen, like it contains H2O, contains oxygen, right? H2O, oxygen element, and large amount of oxygen is trapped in its compounds like silica, limestone, look at the formulas, and oxides of various metals. Silica, sand, SiO2, silicon dioxide, yes or no, calcium carbonates, bicarbonates, or nitrates, nitrites, sulfates, sulfides, all they contains what is the key element? Oxygen is present. So that's why oxygen is one of the most abundant element on this planet Earth, students. Next, preparation of oxygen by the heating of mercuric oxide. So here, by taking mercuric oxide, which is the formula is HGO, which is a reddish substance, by heating, students, what happens? Decomposition reaction takes place. HGO converts to become Hg plus O2. So this O2, when you keep any wooden splint, it burns so vigorously. Why? If there is more oxygen coming, more is the flame. Understood? That proves oxygen is getting evolved in this reaction, and the vaporized form of mercury will attach to the walls of the test tube, and that gives a silvery mirror formation. Why? Because mercury is silver color. So the Bunsen burner, and this is how the complete equipment looks like, mercuric oxide. So this is the reaction, students. HGO converts to form Hg plus oxygen gas. So preparation of oxygen. Next, physical properties of oxygen. Physical properties means solubilities, densities, melting points, boiling points, everything, taste, color. Oxygen is a colorless and odorless gas. No color, no smell. Since the gas has been collected over water, it is not appreciably soluble in water. However, this less solubility of oxygen in water is extremely important for fish and other aquatic animals which are depend upon the dissolved oxygen in water for their respiration. Because of this nature of oxygen getting dissolved in the water, students, all this aquatic life emerges. That is essential component for the survival, yes or no, even not only for the living things on the earth, on the land, even under the water also. And first of all, what scientists say? So where the first life started? Underwater, yes or no? Underwater, not only because of H2O, because of also oxygen present in the H2O. Oxygen present in the H2O means, don't think H2O, not this oxygen. Oxygen gas dissolved in H2O. Understood, students? That's what. So oxygen is slightly heavier than air, and bring a litmus paper near the mouth of the jar full of oxygen gas. you will see that there is no change in its color. Therefore, oxygen has no effect on litmus and hence neutral in nature. So, litmus paper we can detect whether the substance is an acidic or basic or neutral, yes or no. Litmus, if it changes blue to red, it is acidic. If it is red to blue, it is basic. Understood? If it is no change, that is neutral. So, oxygen is a neutral substance. Oxygen can be liquefied on strong cooling it into a pale blue liquid, right? If you can liquefy it, so what is the color of the liquid? Very, very pale blue. If it is in the gas, no color.